It's being presented by Matthias, who is the Global Account Manager for BERG Propulsion. Matthias is going to speak today about BERG's direct drive propulsion electric solution. A brief profile on Mr. Matthias Hansson. He's earned his Master of Science in Mechanical Engineering and Naval Architecture from Chalmers University of Technology in Gothenburg, Sweden. And he entered the maritime industry to follow his passion for propulsion solutions. He has nearly 2 decades of experience in the maritime industry as a project sales and senior manager, and he has a deep knowledge and understanding about the propulsion technology, its limitations and opportunities. Matthias Hansson becomes one of the inventors of the BERG Propulsion's twin fin ship propulsion concept, and also the inventor for the electric direct drive main propulsion solution. And as a global account manager at BERG Propulsion, Matthias manages and leads large and complex projects globally, and also is the link that ensures the success between the internal teams. So, Matthias, the screen is yours for you to share your presentation.
Okay. Thanks a lot.
Welcome.
Thanks a lot for the introduction, and many thanks for us given the opportunity to give presentation here. So share the screen and put in presentation mode here.
Yeah, it's maybe they're not the same screen. Yeah, that's it.
Do you see this? Do you see the screen now?
Yes, we can.
Okay, good.
Yeah.
Yes, thanks a lot for the introduction and for us giving the opportunity to present. Today I will focus to give a presentation about our direct drive main propulsion system. Before I start, I will just give some background of the company. So here we see we are quite an old company. We started in 1912 as a shipyard, and then in the beginning of 1900 we delivered our first propulsion system. And after that point, it was in 1928, we became more specialized to focus the business only related to propulsion systems, various types of propulsion and thruster systems. And yes, we have our global headquarter in Sweden, leadership, and we have gathered our design, engineering, R&D, project, contract, top management, quality, production, control, process, and this kind of systems, including all our production outside of Gothenburg, Sweden, where I'm sitting right now. So this is showing our production facilities for main propulsion systems, thruster systems. We have our headquarter with all these related R&D, design, engineering offices and so on. We have also a separate factory for upgrades, conversions, and also to be able to give fast lead times for spare parts and various types of optimizations of ships. We have Swedish leadership, and we are a global company, so we also have many offices around the world in strategic locations with all the customer related functions like support and services and projects and sales and so on in these strategic locations. We are also having representations by various partnerships also in the majority of the global marine strategic locations all around the world. See here. Just just to give a briefing of the product portfolio. So we deliver our product from small range up to very large size range of main propulsion system. It consists of controllable pitch propeller plants with complete shaft line solutions with conventional propulsion systems. We also deliver fixed pitch propellers. And for our CP propulsion systems, we have also quite a number of associated patents connected with this kind of product portfolio. So we are delivering azimuth thrusters from small up to large size in various configurations, fixed pitch, CPP, L drive, C drive, and so on. And yeah, concerning main propulsion, we are delivering tailor-made solutions for our clients. So we have, for example, configurations with electrical prime movers, mechanical machinery, hybrid solutions with a lot of variety of combinations in order to operate as efficient with as high reliability as possible. We're also building our own hydraulic system, control automation system. We have a separate division for electrical system integration. We also have a separate division for energy efficiency. This is more to support upgradings, conversions to increase energy efficiency on the existing vessels. And yeah, one of the main focus what we have in our teams, where I have a role to support our project and sales team and coordinate with our design engineering teams, is of course to we want to ideally to come in early in the project, because we are also working very much as a co-designer, and we are evaluating various types of concepts. And yeah, we are giving, so to say, the goals and the targets from the clients, what they want to achieve and how they see the future. And by having this very valuable information and their experience, how they actually operate with detailed operational profile, then of course we in some projects there is not so much information given. In some projects we have more information given as an input. And so we are evaluating various concepts, and we provide by conducting various types of calculations and simulation processes. When we have more comprehensive input data, then of course we do the full rated simulation methodologies to present the pros and the cons for our clients in the concept evaluation, until we together as a team select which concept we would like to proceed on. And then of course we want to optimize this to the peak performance level on the total efficiency on the ship. And then by doing so, there is a lot of systems and subsystem components, products that we are combining in this total solution. We also have means to simplify the operation for our customers. For example, the operators and the captains can sit close to like a mode selector, so you can simplify and automating to make the mode selection more automated and user friendly by having certain means for this, all with the intention to determine total tailor-made solution to lower the total cost of ownership. And what we mean with this is of course that we by all means want to push the efficiency to the highest possible level, from the hull design, the integrated propulsion solution, and all the internal systems and components, and in the end you come to the total efficiency for the ship. This picture shows more a traditional setup, which is frequently used. We also see going forward into the future And here we see, for example, combustion engines can be alternative power sources when the energy flow is fed through the gearbox and through the propulsion system. Also, various means of using shaft alternator solution, combination of generators, electric motors for the clients to be able to operate in electric mode. You can use electric motor for a boost function when you need more bollard pull thrust, for example, more power in certain condition, higher vessel speed, and then the energy flow through the power distribution. The concept and the total solution very much depends on the information that we are giving in terms of operational profile, the electrical load balance, and what consumers it will be on the vessel itself. The most important is, of course, trying to minimize the power consumption independently of what drives and where the power comes from. So we want to increase the total propulsive efficiency by the propeller and the hull integration, so we can lower the amount of kilowatts that gives the energy, and then of course try to cut and make each transformation of each step to reduce the losses of the individual components. This one is more on the when our simulations has shown that an electrical system has to be chosen, and this is also a more traditional setup of doing electrical propulsion. In this case, we also see the energy and the flow comes from the power generation sources. It can be auxiliary engines, various types of alternative power sources. Energy is fed through the power distribution via frequency converters, electric motor, gearbox, and conventional propeller system. And of course, it's very important in the analyze to have exact in detail what losses each and every step will bring, and by all means trying to minimize these losses. Here we see an example of more traditional conventional propulsion system connected with electric propulsion with electric motor. And of course, here we have very good cooperation, for example, with ABB. This can be configured in many different ways. The main purpose here with the gearbox is to slow down the RPM on the propeller to get maximum torque capability and to have as high total propulsive efficiency as we possibly can. And then of course have an unincorporated gearbox with built-in thrust bearing to take the axial and the radial forces, because there will be a really high thrust coming from the propeller system. And all this is of course tailor-made, and it can be with single input prime movers. It can be multiple prime movers in combination, vertical offset gearboxes, horizontal, diagonally, and it's a huge variety of how to adapt the correct solution depending on the layout of the engine room and the ship system. This one of the main topic. The main topic today is to present our direct drive propulsion system that what we show here. With this, we have managed to cut some of the. I mean, this is all, of course, tailor-made for each application, and it is when using this solution. I mean, it's quite thorough analysis behind this, of course, and it's something that we do together with the client. One of the main reason of this is that we have eliminated the need for the gearbox. this is more for certain prime direct drive solutions, and for certain vessel applications and requirements where this is where we see a good fit for this solution. Of course, one of the main reasons of this is to increase the efficiency as much as we possibly can with the hull and propulsion system and the integrated solution with this, and to have the highest possible electrical efficiency and the lowest conversion loss of the energy. We have also implemented this solution to avoid having mechanical contact between the stator part where the windings are located and the rotor part where the permanent magnets are located. So between the stator, the outer part here, and the rotor part inside in the tunnel, and there is actually an air gap. So there is no mechanical contact between the stator and the rotor, and the torque is only transferred by the rotational magnetic field. We also see this solution is quite common for certain applications where underwater radiated noise is of importance. And of course, it can be configured in a really as a very compact solution, and it can be adapted totally independent of the ship design. It can be configured for single screw. When we have an electric propulsion configuration selected as a result of our conducted detail analysis, then we see that this solution is more like a premium electrical solution. And so it is totally independent of the ship design. So we can configure this for single screw vessels, for twin screw, triple screw, quad screw, various types of aft ship with open shaft lines, long shaft lines with support of brackets, with twin fin, our patent, or fin skegs, for example, or various types of twin skeg arrangements. So it's totally independent. It's more the definition and how we have solved this arrangement as a direct drive solution. So here we see the various system and components. So this is the conventional shaft line. Here we have there's a lot of, this is a very principle and a very simplified drawing. But here we have the permanent magnet, the rotor part, where we design and manufacturing this rotor shaft. And then we see the stator part coming on like this, so with the completed permanent magnet machine. and we have also we are now also the authorized electrical system integrator for company the Switch Yaskawa, where for the permanent magnet machines, the Switch Yaskawa is building the machines, and we are making the complete electrical system integration and provide the tailor-made solution for our clients for electrical propulsion solutions. Here we see a reference installation. We a little bit further down in the presentation, we will show some reference installation, which we have now in operations since a couple of weeks. But this is actually showing the 3D layout from the propulsion room. Some parts of this equipment is sitting inside the vessel. I mean, it's all inside of the vessel here, but the outer part with this asymmetric fin skeg is leading the water very smoothly to the propeller in order to increase the hull efficiency as much as possible, and then the total efficiency. And the shape and the position, 3D form, and so on is determined by our CFD analysis. So we have also designed the aft ship with this solution. And here we see the integrated directed drive of the propulsion system. And here we see the in front here we have a radial and axial support bearing to take the loads and the very high forces from this extremely efficient propulsion system. And then we see the tunnel where the rotor shaft going through with this air gap and no mechanical wear or contacts. And then we see the stern tube. In this case, we have a water lubricated solution. So it can be configured according to the client's request for either water or oil lubricated arrangements. It's all according to the client's preferences and also what they use in the existing fleet. Here we see another layout drawing of this arrangement. It's a very streamlined, very compact solution. Also, the client in this case was for bulk carriers, very large, quite large bulk carriers. We managed to, because of the tailor-made solution and the compactness of this direct drive solution, we managed to increase the cargo capacity quite a lot, in combination with increased efficiency on the propulsion solution to lower the amount of kilowatt in the various speed and power ranges. Yes, as I mentioned before, this is totally independent of the ship design. So when a conventional system is selected by either fixed pitch propellers or CP propellers with our patented feathering solution, for example, here we see an example of reference installation for a very compact solution, very large propeller system, really low RPM, possibility to increase, to vary the pitch, to really have the full flexibility to control the power requirements and the torque. Here we see an example of a long shaft line, which is commonly used, for example, on ro-ro vessels, RoPax, Navy applications, and then the electrical prime mover is sitting inside at the location of the propulsion room. So it is all according to the request from the clients, where you have space to put this equipment inside the ship. This is where it will be located. But there is a huge possibility to make the drive shaft very short and compact, and connect a large slow turning with the propulsion system with a really high torque capability. And as previously mentioned in the other presentation here, we this solution is flexible to integrate in for existing vessels, for example, or for new buildings, whether an AC bus system will be used or if it will be a DC bus system. It all depends on the project specific details and the requirements from the client. So we have full flexibility, so to say, to adapt the solution to both of these alternatives with either AC and DC bus. So here we see an example, very simplified principle example of power generation from auxiliary engines here, feeding the energy through the power distribution via frequency converter down to the permanent magnet machine. And there are groups for hotel, for example, and also not mentioned in this slide here, but also several other groups for consumers, and power distribution to the bow thruster. But what we have done, what we would like to show, and what we have done in the reference installation, we have used a DC bus system to consolidate the equipment, to cut some of the steps for the power conversion to maximize the total efficiency. And of course, the permanent magnet machine itself has a really high efficiency, and this is rather constant on a very high level, all from maximum load to low loads through the entire power and RPM range. So here we see the energy flow from the power generation, in this case with auxiliary engines. You're feeding the energy through this DC hub with built-in variable frequency drives. Of course, when we provide a solution like this, is a complete system with the PMS and DC hubs and all the components to generate for the power distribution. And then we see here from the DC hub with the VFDs built in, feeding the energy through the electric motor, hotel, and the bow thruster. So we can see if I change back to the previous slide, you see there is some components that we were able to consolidate and make this in a more compact and streamlined way. And this solution is of course also fully flexible by adapting different types of battery solutions, energy storage, alternative power sources, or combination of this according to the client's request, and also having the possibility to make the power generation to minimize the gensets, for example. So there's a lot of flexibility, actually full flexibility for the future adaptation. What we wanted to do with this solution is of course to have the full flexibility to control the torque and to maximize the efficiency with the hull design and the integrated propulsion solution, to lower the amount of kilowatt for the drive system and the permanent magnet machine, and then of course minimize the conversion loss by all possible means to and then of course have certain mode selections that the clients can use depending on the operational needs and functionality. Here we see an example of a single line diagram. It's simplified, but where we see the power sources, the DC hub, main propulsion solution, thrusters, various types of groups for power distribution. This is the reference installation. To give some information about this, we have taken full responsibility in this project and delivered the complete main propulsion solution, rudder system, electrical integration, thrusters, and this has the electrical drive, the direct drive solution. So we have the permanent magnet machines in each asymmetric fin skeg connected with our propulsion solution. So here we see the layout of this just before launching. So this is the reference installation is a 26,000 deadweight bulk carrier and a self-unloader Laker for the Canada steamship lines. It will operate in North America on the Great Lakes and also between Canada and United States. So here we see the vessel since a couple of weeks in operation, and feedback from the client of course is they are extremely happy. First of all, the solution is extremely silent, very quiet in terms of they with minimum amount of really low extremely silent and also extremely efficient. So they were able to cut a huge amount on the fuel. So this solution was really perfectly configured for their needs and their application. And they also believe that they would like to create a future trend going with this kind of solution. So we see a high possibility and the potential to to have this solution integrated in many different types of ship segments where applicable, but it all, of course, depends on the information that we receive from the clients.